Okay, so again, everything on this page is about that equation y equals x plus 4. I picked negative 10 and 5. You guys pick some other numbers maybe in between. When you plug negative 10 in, we get negative 6. Is that right? Is that okay? And then we plug 5 in and we get 9. And so that leads us to some points, 5, 9, and negative 10, negative 6. And then we can plot these 2 points. So let's see, negative 10, negative 6 is way down here, and then 5, 9 is near the top right there. And then you're going to have another 2 points that you plotted, but the idea is that it doesn't matter what numbers you picked over there, they're going to be on the same line that these two are on. And so we can connect the dots and get the entire line. And then part C says decide which of these ordered pairs are solutions to that equation. So for example, if I wanted to look at 6, 2, how could I tell whether or not 6, 2 satisfies that equation? Yes. We plug in the 6 and the 2. You got to plug them in the right spots. First number is always x. So we plug in the y is the 2, okay, equals, and then the x is 6 plus a 4 here at the end. I'll put a question mark below the equals. But everybody sees the substituting that we did? Is that equation true or false? It's false. So is 6, 2 a solution or not? Not. Graphically, how could we know whether or not 6, 2 is a solution? Yes, in the back. We plot it. Okay, I can plot that. 6, 2. Now what? Doesn't fall on the line. So it's not a solution. That's it. There's this really important connection between the equation, the solutions to the equation, and the graph of the equation. That graph represents all of the solutions to the equation. If you're on the line, you're a solution to the equation. If you're not on the line, you're not a solution. Okay, running through just to get the answers up here, negative 5, negative 1, did that work or no? Yeah, that one worked. How about 0, 0? Nope, 4, 0? 4 zeros and no. We got to plug in the right order. X is the 4. So this one is a no. Negative 4, 0? That one's okay. 0, 4? That one's okay. And 6, 2 we've already decided is a no. Okay, we'll graph the entire line. That's all the solutions. Then we talk about the quadrants. So this is just something to memorize. I don't know what else to tell you. Quadrant 1 is the quadrant where both x and y are positive, which is up here in the top right. It makes sense to call that quadrant 1 because that's where everything is positive. And then we go around in a circle. We got to decide which way to go. I don't know why, but we go counterclockwise. So this is 2, 3, and 4. Generally, we use Roman numerals for the quadrants. So which quadrants does that line pass through? 1, 2, and 3. Okay, and then the last question is just another vocabulary one. It says, is the line increasing or decreasing? Well, this one seems kind of open to debate because if you have like let's say a mountain climber here, oh, that's sweet. And this person is walking left to right. From his perspective, is he walking uphill or downhill? Uphill. So he thinks this is increasing. But then you have the skier up here, and let's suppose that she is going right to left. Is she going uphill or downhill? Downhill. So whether it's increasing or decreasing just kind of depends on your perspective. Are you going left to right or are you going right to left? Okay, so the good news is it seems like you could make the case for either answer. The bad news is one answer is right and one answer is completely wrong, and we got to get the right one for the tests and the quizzes. So I will tell you that everybody in the world has decided we are going to walk left to right. Everybody in the world has decided we will walk left to right. So walking left to right, is that increasing or decreasing? Increasing. So I'll put down here always walk left to right. You see a question about increasing or decreasing, walk left to right. This line is, which one? Increasing, left to right. Someone in my earlier class, I teach one right before this one, made a nice connection about slope, which we will talk about soon enough. It's okay if you know nothing about slope, Is the slope of that line positive or negative? It's positive. And so there's something nice about saying a positive slope corresponds to going uphill, to increasing. Again, if you don't know anything about slope, don't sweat it. All right, let's go back a page. We'll go back to number 1. Okay, there are 2 equations, 2 linear equations for you guys to solve in your groups. Slowly and carefully and with help from each other, see if you can solve those 2 equations. All right, so let's talk about the first equation. First thing to do to both sides is subtract 3, that's okay. And then divide everything by 5, x equals 4. Questions on the first one? Okay, first one's much easier than the second one. Second one is so hard that I made a mistake. I make mistakes all the time, so it's not that surprising. But I made a mistake on the second one. What did I do wrong? Why should this be -8? That's right, I like that word right there. That -2 is going to distribute, and it's really common to forget to bring it into the second term, the third term if there were one. So I made a really, really easy mistake to make, and that's to just do 2 times +4 and write +8. It's really -2 times +4. So this guy should have been, oops, let's keep that in black, -8. And then 3 minus 8 should have been -5. So that part's okay. So this guy, I guess, should have been -5. So is that right? -5/8? No, I didn't. Yeah, let's call that mistake another one that was intentional. All right, so that should have been 10x, and this guy, we should divide both sides by 10. Okay, so that gives us our final answer of -5/10, and I'm always expecting folks to reduce fractions. What does that guy become? -1/2 is good. All right, so this is not the lowest math class that GCC offers. We have several that are below this one. So by virtue of the fact that you are in this room, there are certain things that we assume you know how to do already. And solving linear equations is one of the things that we assume you know how to do. In fact, the first 2 pages of this big packet that we skipped over are key prerequisite skills. And part of your homework tonight is going to be to go through, if you have difficulties, significant difficulties with some of the stuff on the first 2 pages, come talk to me soon. We got to make sure you're in the right spot. It could be you just have some rust that you can shake off with a little bit of work. It could be that maybe there's just too much rust and you need to take a step back. Wherever you are, I want you to be in the right class. Maybe it's this one, maybe it's not. But part of the homework will be to kind of figure out where you are in terms of those prerequisite skills. Okay, let's take a look at number 2. Number 2 has fractions in it. Fractions scare a lot of people. Looking at the 2 symbols over here on the left-hand side that I'm going to circle. If I say those 2 symbols out loud, I would say divide by 2. Yes? What's the opposite of what I said? Multiply by 2. And that's how we get rid of the fraction. So we'll multiply both sides by 2. And now I'm going to do something really simple but really important. What happens to the 2's on the left-hand side? They cancel and you cross them off. That's why you put the 2 there, was to get rid of the 2 that was in the bottom. So you canceled them. And we're left with our answer, x equals 6. Same deal on the other equation. I see divide by 2. I do the opposite, which is multiply by 2. Both sides. All right, there are 2 right ways to proceed and 1 wrong way. Let's make sure we don't do the wrong way. The wrong way is to say, okay, that 2 is here and it's here, so on the top I get 10x and on the bottom I get 4. What's wrong with that? Yeah, the 2 is there to get rid of the other 2. That's why we put it there, not to multiply. Furthermore, if I had to decide whether the 2 was on top or bottom or both, which is what I wrote down here, where is that 2 in red? Top or bottom or both? Just the bottom? Yeah, if it helps you, put over ones. That will really clarify whether things are on the top or on the bottom. So that 2 is only on the top, not on the bottom, not both. Okay, so we can't do what I did here. And I'll show you another way that's okay, well, a way that's fine but not recommended. You could multiply on the top. Don't write this down. But on the top is 10x. On the bottom is just 2, right, because it was over 1. And then you can reduce that. What is that really? That's really 5x. It's fine. But I don't want you to do it that way. I really like what this gentleman in the back here said. The 2 is there to cancel, not to multiply. So even though it's okay to multiply the 2 and the 5x, why? Why would you do that? You put the 2 there for the sole purpose of getting rid of the 2 on the bottom. So cross it off. Don't be tempted to multiply. And so then we'll write down on the left-hand side is just 5x. On the right-hand side is 6. Divide both sides by 5. We get 6/5. Any questions on that one? Okay, let's take a look at 3. So 3 is worse than the ones that we just saw. Now there are fractions in 2 different spots, and there's also parentheses. Okay, now there's one thing I want to mention about this last equation here. Sorry, take a quick step back. Looking at this guy, I see multiply by 5 over 2. That's what that is. That's multiply by 5 over 2. What's the opposite of multiplying by 5 over 2? It's multiplying by 2 over 5. That's the opposite. So if you multiply both sides by 2 over 5, you will zip to the right answer in one shot instead of 2. It's quicker. It's more efficient. It's what you're fine. It's fine to do that. But what I'm after generally in this class are techniques that apply to wide classes of problems. And I'm not really going to show you these like one and done tricks that apply to really specific kinds of problems and don't really help you in most cases. So it's fine to go the really efficient way, multiply by 2/5. I'm generally not going to go that route. I'm looking for broad techniques. Okay, so looking at number 3, there are 2 ways to go about doing this. Some people feel obligated to distribute. Whenever there's an opportunity to distribute, you must distribute. You don't have to. You can. You're totally welcome to distribute. If you distribute, this guy will become a 5/3 x. This guy will become some fraction that I can't figure out right now. And there'll be a lot of fractions floating around. Yeah? It's going to be pretty messy. Turns out there's a better way. So let's go to the better way. The left-hand denominator is a 2. The right-hand denominator is a 3. What's the lowest common denominator for those 2 fractions? It's a 6, right? Folks know that a 6 is what 2 and 3 both go into. So here's what we're going to do. Instead of making a common denominator of 6, we're going to multiply both sides by 6. All right, so we're going to put a times 6 over on this side, and then times 6 over on this side. Okay, so let's do the good news on the left-hand side. What happens with the 6 and the 2? They're going to reduce. What will be left over when we reduce? Just a 3 up on top. Okay, so then I'll have a negative 3x on the left-hand side. Nothing else. And the fraction went away. That's great. Okay, the right-hand side is trickier. So let me give you a simple example to think about first. 2 times 3 times 4. Would you guys agree that I could first multiply the 2 and the 3 and get 6, and then multiply the answer by 4? That's okay? Would you also agree that instead I could multiply the 3 and the 4, leave the 2 in the front? 3 times 4 is a 12, still the same. Or if I was really interested, I could multiply the 2 and the 4 together, and then do the 3 at the end. Right, it's 24, no matter how you slice it. So we have 3 things multiplied together, and we can just multiply any 2 of them first that we want to. It's called the associative property. So I have 3 things here. 1, 2, and 3, all multiplied together, yes? The fact is the thing in the middle is a little bit complicated. It's in parentheses, it's x minus 65. But those are three things multiplied together. So we can choose to multiply any two of them that we want. I'm going to choose to go this route that I went last year because I just want to mush together the two numbers that are sitting outside. And then we'll copy down the thing that's in the parentheses. So really what I'm after is 5/3 times 6. Okay, you are welcome to multiply 6 times 5 and get 30. Divide by 3 is 10. I would much prefer you do something else. What would I prefer you do instead of 6 times 5? What's that? Reduce. What can we reduce? The 3 and the 6. Let's reduce. What's left over? 2. 2 times 5 is 10. It's not that big a deal in this case. The numbers are all small. But if the numbers were really bad, then maybe multiplying would give you some really enormous number that you'd have to divide anyway. So I think it's better to do it that way. So we get 10, and then x minus 65 is still sitting there. That step that we just did is not trivial, so I want to make sure everybody's okay with it. We had three things multiplied together. You can choose to multiply any two that you want and then do the third one last. I chose to multiply 5/3 and 6. I got 10, and I do the third one last, x minus 65. How is this equation better than the first one? No fractions. That was the goal. We got rid of all the fractions in one fell swoop by multiplying both sides by the LCD. Super. Okay, now what should we do on the right-hand side? Now we'll distribute. There isn't much else that we can do, so distribute that 10. We don't have to do the 6 to the x times. That's part of what makes this tricky. Is that it feels like we should have to do the 6 and the 5/3 and the 6 with the x minus 65. But coming back to this example with the three numbers, we're not multiplying. You don't put that 4 into both of them, right? It's just a single multiplication by 4. You can choose to multiply any two together that you want. That's what we had up here. There's one multiplication and there's the other. So even though parentheses kind of screams, hey, do the distributive property, it's x minus 65 in my mind is one thing. It's like the 3 in that green number problem over there. Yeah, good question. Okay, there's no wrong answer to whether we want to move the x's to the left or to the right, but there is an easier answer. Is it easier to solve this problem by moving x's left or right? Let's move them to the left, because if you move them to the right, then you still have the 650 to contend with. So let's subtract the 10x from both sides. And so that's negative 13x equals negative 650. And then do what to both sides? Divide by 13. Anything else we might do? Yeah, how about we divide by negative 13? That'll get rid of the whole thing in one fell swoop. Okay, so we'll get our answer here, negative 650 over negative 13. It's possible it goes in evenly. It's not likely that it goes in evenly. That said, I would take off like a point or half a point if you left this as your final answer on a test or a quiz. How can we? Yeah, we see two negatives divided by each other. They cancel. So for full credit, you got to get rid of two negatives anytime you see division. Questions on that one? All right, that one's not easy, but it does bring in a technique that we're going to be using during the semester, is this LCD business to get rid of fractions. Okay, so let's take a break from the packet and go to the other document that you have in front of you. It's much smaller. It's a syllabus. All right, my goal is to fly through this in less than 2 minutes. Let's give it a shot. Part of your homework is going to be to read through this in more detail tonight. Okay, my name is Ian. Don't bother trying to pronounce my last name. My work and home phone numbers are there. The fact that my home number is there means it's okay to call me at home. I don't have email when I'm at home, so if you really need to reach me and it's time sensitive, then phone is always better than email for me. Okay, my office hours are down here. There's information on the textbook and the calculator that you might need for this class here. You are welcome to read the catalog description. The department has some general goals for every math class. On the next page, there are specific goals to this math class. You can read through those later. Expectations. Okay, so one thing you might notice is that the math classes here at GCC don't have those standard single desks where one person is sitting at a desk and there are lots of rows of desks. We chose these trapezoidal tables so that we could do some group work together. You guys are already working really well together, so continue to do that. If you want to move to a different table, feel free. You can sit any place you want, any day you want. If a group isn't working out for some reason, talk to your group and or talk to me. I want this to be a good experience for everybody. And I think having people work well in groups will really make that experience better for all of us. All right, two things that I expect: attendance and conduct. Essentially just be respectful. I'm sure we won't have any issues. Resources. I am one of your resources. On the next page, other students in the class are your resources. Try to learn their names as soon as you can. Yeah, that's good. Might be a good idea to get phone numbers or email addresses from some of your table mates so you can communicate. There's free peer tutoring available. I think I'll have somebody come into our class and give some details on that pretty soon. The Math Studio is right across the hall. Raise your hand if you've never used the Math Studio before. Okay, just a few. So in a nutshell, the Math Studio is this space right across the hall. It is often staffed by a math faculty member who's there to answer questions that you might have on homework or if you're studying for a test. I will hand out the schedule when the studio will be covered by math faculty as soon as it's printed. It should be in soon. On your official schedule, you saw 10 to 10:30, I think, was in the Math Studio. Our class officially starts at 10:40 and runs until 11:50. And that's the only part that you are actually responsible for being here for. But we build in this studio time so that people can get their homework questions answered before class and work with each other. So I encourage you to treat that as part of the class officially and just make it a habit that every Monday, Wednesday, Friday, 10 to 10:30, you're in this room asking questions. There are going to be two different math faculty members on duty every day right before our class. There's also somebody there right after our class from 12:10 to 12:50. There's a lot of coverage. So this is a really nice resource. Okay, there's free tutoring online. You can check that link out for more information. In terms of your grade, I will be grading homework every day. There are quests and tests. Quest is a combination of the word quiz and test. They're a little bit longer than a traditional quiz, but they don't involve as much material as a traditional test. So we put those two words together, and there's a final exam. You can read through the makeup policy. Down here are the percentages. Your homework is 10%. The quests are 45%. I think we have 5 or maybe 6 of these guys. There are 2 tests where 30%, and the final exam is 15%. Now, in terms of the homework, I will get here early on Wednesday and every day, and I will check homework for anybody who's here early. You're not actually going to physically hand me the homework. Much of the work you do is going to be in the textbook, so I'm not going to take that book from you. So try to get here a little bit early, maybe 10, 15 minutes early, and we'll get that homework check done. If you aren't able to get here early or I'm not able to check your homework before class, I'll ask you to stick around for just a few minutes after class. Generally speaking, I grade your homework on completeness versus correctness. If you just want correctness, you can copy the answers from the back of the book. They're all there. That's not the goal. Right? So I want to see you've made an honest effort at these problems. That's what I'll be grading you on. Questions on any of this? Yes?
I can do that guy, but do you have like a certain amount of days?
Good question. So officially, attendance is not listed here. You could be absent every day if you want to. But if you're absent every day, you're going to get zeros on the test and the quest, and that's not so great. So attendance has a very strong link to grade. Like there are studies that show that going to class is a really good way to help your grade. But I know that emergencies come up. If you have to miss a quest or a test, any kind of lead time you can give me will make it easier for me to give you a makeup exam. If you just don't show up, it's a 0. Right? Does that help? Yeah, no, there are no penalties explicitly here for missing class. Good. Other questions? Okay, on the next page it talks about the letter grades, talks about some resources on Moodle. Maybe we'll take a look at some of those next class. If you have special needs or accommodations, please let me know. I want everybody to be successful in this class. And then the little paragraph on academic honesty, ironically I copied that word for word from the GCC catalog. Okay, this last page here is a really important document. It's our schedule. I'm going to pull up a version of exactly the same thing. It just looks a little better if I show it to you in Excel. So this lays out exactly what we are going to be doing every day of the semester. So if you're ever not sure of where we are, this is a good place to go for information. You can find out the dates of the quests and the tests. For example, our first quest is coming up on February 10th. Mark your calendar. It talks about the sections that we will cover, the page numbers of the sections, and the page numbers of the answers. Normally I wouldn't put page numbers in. You guys could generally figure out where, if I say section 1.5, I trust you can find that in the book. That's with the traditional book. This book that you guys have for this class is a Frankenstein book. It's actually two different books mushed together, and it's specifically designed for GCC, which is what it says on the cover. So actually finding things in this book can be quite confusing because the page numbers don't go in order. So look through here. This should help you find exactly where stuff is supposed to be. Also the answer keys. The answer key is sometimes hard to find answers, so use this document for that as well. All right, I know it's a lot of information. You'll read through it and bring questions next time. Any other questions on the syllabus here? Yes?
So, as far as homework, is it all the problems?
Good question. What about the homework assignments? All right, so let's jump back to the big packet. We're done with the syllabus. Now we're going to jump to this page, number 8. Page 8. At the end of every day's set of materials, you will find this phrase, learning objectives after class number blah. Today is class number 1. This is where you're going to find your homework assignment. So for before Wednesday, you're going to do this reading there in the book. You're also going to read through the syllabus. You're going to complete a group activity that you will start momentarily, but you're not going to turn it in. I generally don't collect the group activities. You are going to show me the homework for the textbook, right? So that's from this particular textbook. It's not all the problems, it's just these ones laid out here. And then in this case, there's another assignment where you're going to tell me a little bit about yourself as a math learner. And then sometimes here you'll also find announcements and reminders. All right. If you don't yet have a copy of the textbook, there's a copy in the Math Studio on the bottom shelf of those bookshelves in the corner. You're welcome to use it in the Math Studio. There's also a copy of our book on reserve in the library. So until you get your book, there's no reason to not be able to do the reading and do the homework. Just means you have to find your way to the studio or the library. Okay, so for the rest of class, what you guys are going to do is work through this very long activity. It starts here on page 5. We have about 30 minutes to the end of class. That might be enough time to really work through if you guys are motoring. There are little flags on the table. If I can help in any way, raise a flag and I will come over.